What's up, everyone? This is LeetCode 17, letter combinations of a phone number. We're doing this in C++, done this in Python already. I'm just going to summarize the problem. Basically, our input can be two digits, right? For example, example 1, we're pressing the 2 and the 3. We basically have to return the possible letter combinations that that input can represent. For example, this 2 is ABC, this 3 is DEF. So what is the possible combinations, right? We could have AD, AE, AF, or BD, BE, BF, or CD, CE, CF, right? Kind of the gist of the problem isn't too hard. The solution's a little bit trickier, but basically what it's asking of you isn't too difficult. Okay. For example, 2, right? You press the 2, it could be A, B, or C. Okay. So because we're in C++, we're gonna have to write out a helper function as we solve this. We're not gonna solve it just yet. But just gonna write that private because we will use a helper function. So in essence, right, you can think of it as nodes if it makes it a little bit easier, right? We have a 2 and then a 3. This 2 can represent A, B, or C. This 3 can represent D, E, F, right? And so your solution would look something like this, right? And this is actually a backtracking problem if you can't tell. The reason for that is because really when we're exploring possible paths, we could go from this A to this. When we go to the A to this D, right, that's one path. Then we could go back up and then look at this path. That's another path. And we go back up and look at this path. It's another path. Then when we're done with the A's, we go to the B's, right? This is one path. We go up. This is another path, and go to the C's, right? One path, another path, another path. Now we've done a few backtracking problems in the past. I think we've done one or two. You generally have a base case to stop. And the way we're going to do this basically is we're gonna keep track of a string that we're building out, right? Initially, string is gonna be empty, right? And we're gonna grab one letter, right? When we press this 2, we're gonna explore the A's first. So we're gonna have these A's, and then we're gonna go down here, we're gonna add the D, right? And then we're done, right? Well, how would we be done? Well, that's because our base case would basically be the length of this string that we're building out. When that's equal to the length of the digits, we're done, right? Because if we press 2, 3, well, the length will only be 2 letters, right? When we press 2, 3, right? You can see we'll only have 2 letters. It'll never be 3 or anything. So basically, the length of this string that we're building out, when that's equal to the length of the input, that's basically when we know we can backtrack and explore other paths, okay? So just kind of letting you know that's basically how we're going to handle our base case. So there's quite a few ways you can approach this, but a lot of the other ways are way more complicated. So we're actually just going to end up using a hash map, okay? And mapping the numbers to the letters like this, okay? So this is how we're going to do it, okay? And remember, this is a backtracking problem, so we're going to have to do some recursion, right? This is just some boilerplate stuff, right? For our answer, let's set up a vector string so we can actually return this. And we're gonna have to have a backtracking function, right? And really, the only two things that are important, these are just references, right, that we're gonna need. But really, these are the two important things. Is we're gonna need the index and the empty string, right? Initially, we're gonna start at the 0th index, and we're gonna build out the string. This is all just stuff that we need for our helper function because they're gonna be references. But okay, I don't really want to write all this out. I'm just gonna paste it. I'll explain it. Okay. So yeah, we just have our index and then our current string. And then these are just references, right? This is our input, this is our hash map that we're going to use, and this is our answer array, okay? But again, our most important things are really just our index and our current string that we're building out. This is initially empty, and our index is 0, right? So remember our base case? What was our base case? Our base case is if the length of the current string is the same length as the input. So that would basically be where we would have to stop. Okay, so we're going to say this current string size equals to digits.size. And remember, digits.size, the input is actually a string. You'll look at line 12. So that's why we can do this. Okay. If that's the case, then we'll do answer.pushback current string. If it's been a while since you've done some sort of backtracking problem, just do the problem called subsets. That one's pretty simple. Just to get a feeler on how you do backtracking and kind of understand the logic behind it. But this is just setting up our base case basically right here. Nothing too important, right? When we hit our base case, we're gonna basically append to our answer array. Okay. Now here's where our actual work comes in, which is basically we're gonna do this is actually, sorry, that was not aligned properly. It was actually annoying me. Okay, so now this is where our bulk of our work's gonna happen, right? We're gonna say string letters is equal to digits map digits index. Okay, so initially we're at index 0, right? So when we're looking at digits, right, like our input is 2, 3. At index 0, we're grabbing this 2, and we're putting that into our hash map, right? And what should we get in return? ABC, right? So string letters is just going to be ABC. Okay, that's all this is getting basically. So this string letters is going to be ABC. Okay, so we need to iterate through that, right? So we're going to say for char letters, we're going to do backtrack index plus 1 current string plus letter, right? And this is references, so I'll just put it on a different line. So, because these are not really that important. I mean, they're important, but we're not doing much with it. Okay, that should be it. I will explain this here. So, our index is 0 initially, right? So when we're iterating through this input digits, right, 2, 3, right? So our input is 2, 3. Our index initially is just 0. So we're going to basically grab this and put that into our hash map. And we're going to grab what? ABC, right? So letters is really just ABC. And then we're going to iterate through letters. So we're going to grab this A first, right? And so we're going to grab this A and recurse into the function up an index, right? And our current string is going to be what? Current string plus letter. Well, current string initially is just an empty string. So an empty string plus letter, so that would be what? Current string then would just be A. Okay, so our current string is A. We're going to recurse into the function up an index, so that would be what? We'd go to the 3. So current string is A. We're going to go up an index, and we're going to explore what? DEF, right? So then we explore the D, because we're going to do the same thing, right? We're going to do for char letter and letters, but again, this time the index is not 0 but 1, so we're going to look at this, right? Up here, letters is going to be DEF. We're going to do, when we do current string plus letter, right? We're basically doing A, AD, AE, AF, right? And we will hit our base case at some point, because this will be true. And that's when we're going to add it to this, okay? And build out our answer. So yeah, I don't think this problem is too complicated. I think, honestly, when I did this problem, I was a little confused, but it was just because I haven't done backtracking in a while. The hard part about this problem really is just understanding your call stack, like what you're doing at each step. I don't think this code is actually that complicated. If you're a little bit lost or confused, honestly, I think if I had to guess, it's probably just because you haven't done backtracking in a while. So my suggestion is go do the problem called subsets, and it'll make more sense. This problem, it really isn't that complicated. It's very similar to subsets. Like, it's rather simple. The only thing that's a little bit strange about this problem is your backtracking is in the for loop, but overall, I don't think this problem is that complex. You just need to understand your call stacks, and you need to understand how you're doing backtracking, right? If you don't understand how you're doing backtracking, you just haven't done backtracking, or you haven't done it in a while, in which case, go do the subsets problem, and you'll be fine. But anyways, I hope this helped. And yeah, I think the hardest part about this problem is just setting up this unordered map. You probably wouldn't think to do that, but it is very useful. Anyways, I hope this helped, and I'll see you in the next one. Peace out.